Assalamualaikum. My name is Zurain Alisa Maliki and I am from Group O. Today, me and my partner Nuraliana will present on the topic of polymers. This presentation is under the guidance of our lecturer, Dr. Nur Afika binti Badli. So, for the polymer, it can be seen from the clothes we wear to the technology we use daily. Polymer is a part of our everyday life. So in this presentation, we will discuss the definition of polymers, their types, reactions, and applications in daily life. Okay, so let's begin with the basics. What is a polymer? The word poly, derived from Greek, means many. Polymer is a long-chain molecule that is made from a combination of many repeating basic units. What is basic unit? Basic unit of a polymer is known as monomer. These monomers bond together through a process called polymerization reactions. To simplify, think of a polymer as a bracelet. The individual bits represent them as monomers, and the chain holding them together is a polymer. Next, we are going for the source of polymer. Polymers are classified into two major categories, which is natural polymers and synthetic polymers. For the natural polymers are polymers that are naturally available and can be formed from our surroundings. For example, starch, protein, and cotton. For the synthetic polymers, these are man-made materials produced through chemical reactions, such as nylon and polystyrene. So these are the examples of the name of polymers and monomers. Basically, you need to know all of these. Okay, so I'm gonna call out one example. As I mentioned earlier, the combination of monomer will produce polymer. So for the natural source, we know that the combination of glucose will produce starch by polymerization reactions. Same goes with the combination of glucose will produce a cellulose. Next, we are going for the types of polymers. There are three types of polymers, which is thermoplastic polymers, thermostatic polymers, and elastomer polymers. Okay, for the first one, thermoplastic polymers. A polymers that can be repeatedly remolded upon heating and can be recycled. For example, nylon and polyethylene. When heated, the thermoplastic polymers melt and solidify when they are cool. For your information, thermoplastics are widely used in packaging. Okay, for the second one is thermostatic polymers. Unlike thermoplastic, these cannot be remolded or reshaped after heating, and it is also cannot be recycled. For example, melamine. The third one is elastomer polymers. These polymers have high elasticity, meaning they can stretch and return to their original shape, such as polyurethane. Polyurethane is one of the examples of an elastomer polymers that is used in making rubber and tires. Next, polymerization reactions. Polymerization reactions is the process by which monomers combine to form a polymer. It is also divided into two main types, which is addition polymerization and condensation polymerization. For the addition polymerization, it occurs when monomers that have double covalent bonds between two carbons react with one another. Example of polymers that are produced through addition polymerization is ethene, which is monomer produces polyethylene, a polymer. During the reactions, the double bond is opened and monomers are added to the molecule chain to produce a polymer. Next, for the condensation polymerization, it involves at least two different monomers. The monomers involved consist of two functional groups that will take part in polymerization reactions. The product of condensation polymerization is a polymer that another byproduct, such as water and HCl molecule. This is the example for the additional polymerization. Ethene molecules combine to form polyethylene. You can see the monomers with double bonds react to form a polymer, which is polyethylene. One example for the condensation polymerization, it involves two or more different monomers with functional groups and produces not only polymer but also byproducts such as water and hydrogen chloride. Okay, so next we are going to talk about the use of polymer in daily life. What is characteristic of synthetic polymers? So we know that polymers are an essential part of our lives due to their unique properties. So what is the characteristic? It is good insulator of heat, unreactive and lightweight, strong and hard and resistant to high heat. Next, we are going for the uses of synthetic polymers. Okay, synthetic polymers are used in various medical laboratory apparatus, such as polypropylene and polyethylene as a plastic bags and nylon to produce threads. The last one is the examples of synthetic polymers. To summarize, polymers are long-chain molecules formed from monomers. They are classified into two types, which is natural and synthetic types, and can further be divided into thermoplastic, thermosetting, and elastomeric polymers. So that's all from me. At this point, I would like to pass my presentation to my partner, Juliana, who will elaborate further more on the polymer topic. Bye.
Assalamualaikum. Today I'm going to present you about natural rubber. So the first one is the history. Rubber tree, or the scientific name is Hevia bacillus, was brought to Malaysia in 1817 and has continued to be developed as an important commodity in our country until the present day. Among Malaysia's major exports are rubber gloves and coutures. Latex is a white fluid obtained from rubber tree when the tree bark is thick. Natural rubber that is found in a latex is a natural polymer known as polystyrene. Latex is a colloid and not a solution. Rubber particles do not dissolve in water but disappear separately in water. Monomer for polystyrene is isoprene, or with the IUPACs named 2-methyl but 1,3-dina. The protein membrane for of rubber particle is negatively charged on the outer surface. This is cause rubber particles to repel each other, preventing coagulation. So for the characteristic of natural rubber is rubber depend on rubber polymer that are natural elastomeric polymer. The presence of double bond in the rubber polymer structures affect the resistance of natural rubber towards oxidation by air. So, for the vulcanization of rubber, okay, the first one is definitely is definition of volcanic vulcanization of rubber. So, what is vulcanization of rubber? It is a process of product rubber that is more elastic and with better quality through the product or of cross-link between polymer change. So if you guys can see, this is a picture about vulcanization of rubber. So for the alternative vulcanization method, it has three. So it's a peroxide, iodination, and metal oxide. So for the vulcanization by using sulfur in the main metal used to product vulcanized rubber from natural rubber. So for the number two is, nonetheless, the vulcanization method cannot be used for content types of rubber, particularly scientifically rubber which does not contain C double bond. There are a few alternative vulcanization methods that can be utilized to product vulcanized rubber without using sulfur. Vulcanized rubber products is a free from sulfur and more environmentally friendly. Okay, for the illustration of elasticity of vulcanized rubber polymer, it have before stretching, during stretching, and after stretching, as you guys can see. So for the unvulcanized rubber polymer, okay, before stretching it has a sulfur cross line, and during stretching and after stretching you can see the different shape it had. So for the last one is the difference between vulcanized and unvulcanized rubber. Okay, so for the character is elastic, hardness, strength, and resistance toward heat. And the last one is resistant towards oxidation. For the vulcanized rubber is more elastic, hard, height, resistant to high heat and more resistant to oxidation. And for the last one is unvolcanicized rubber is less elastic, soft, low, less resistant to high heat and easy to be oxide. So that's all for me. Thank you.